All right, let's get right into another deep dive. This time, we're going to be tackling something that I know just about everyone finds absolutely fascinating, and that's the extinction of the dinosaurs. We're going to be looking at a video from the History Channel and basically try to sort through all the evidence and the different theories surrounding this event. And who knows, maybe we can uncover some insights into our own future while we're at it.
Yeah, I think it's one of those things that really captures people's imaginations, right? Like these giant creatures that ruled the planet for millions of years, and then poof, they're just gone.
It really is incredible when you think about how long the dinosaurs were around.
Mm.
Like this video reminds us that they ruled for 150 million years. I mean, that's longer than like the entire history of mammals, right?
It is, yeah. And it's easy to think of dinosaurs as just these big lumbering giants. But they were so diverse. They evolved and adapted to all kinds of environments.
They're everywhere, right?
Yeah. And I think something that often gets missed is that they were actually incredibly successful. I mean, from an evolutionary standpoint, they weren't just these kind of slow, sluggish behemoths destined to go extinct. You know, they were constantly evolving. They were filling all these ecological niches. And they showed a remarkable amount of resilience. So their disappearance really raises some profound questions about the balance of life on Earth.
So let's talk about the Chicxulub impact. That seems to be kind of the main suspect, right? The video paints a very vivid picture of this massive meteorite slamming into the Yucatan Peninsula 65 million years ago. It's described as being billions of times stronger than the atomic bombs that were used in World War II. So just an unimaginable force.
Yeah, it was a cataclysmic event, and the evidence for the impact is pretty compelling. We have the massive Chicxulub crater, of course, and then within what's called the KT boundary layer, that's the geological stratum that marks the end of the Cretaceous period, we find traces of iridium. That's an element that's actually pretty rare on Earth, but it's abundant in meteorites.
Oh, okay.
So that's a big clue. And this KT boundary layer also shows evidence of widespread wildfires, suggesting that the impact probably ignited these massive global infernos.
So like right out of a movie, basically, like some apocalyptic scenario. But the video doesn't just present this impact theory as like a done deal. It also points out some interesting challenges to it. Like, for example, if this impact was so devastating, like wiping out dinosaurs instantaneously, why haven't paleontologists found all these massive dinosaur graveyards,
Yeah.
like right within that impact zone?
Right, yeah. That's one of the puzzles that scientists are still trying to figure out. And it leads us to this question of whether the impact was really the sole culprit or if it was just one part of a much more complex story.
So are we saying that like the impact theory is wrong then?
Not necessarily, no. I think it's more like the impact might not have been the be-all and end-all of the extinction event.
Yeah.
What's really interesting is that the video highlights all these other environmental factors that were at play during the late Cretaceous period. And these factors could have already been putting a lot of stress on the dinosaur populations.
So are we talking about like a perfect storm situation then? Like where the impact was maybe just the final blow?
Exactly. And one of those factors was climate change. We know that sea levels were falling during this time, and that led to changes in ocean currents and global temperatures.
I see.
So imagine these massive dinosaurs, some of them weighing tons. They would have needed enormous amounts of food and water just to survive. And how well could they really cope with a rapidly changing environment?
Right. Yeah, that makes a lot of sense. The video actually compares this to modern-day elephants.
Oh, right. Yeah.
Like they're also very large and slow-breeding animals. They have huge appetites. And they're incredibly vulnerable to things like habitat loss and environmental changes.
That's a great analogy. And it suggests that size, which might have been an advantage for dinosaurs in stable environments, could have actually become a liability when things started changing quickly.
So we've got climate change as one possible factor here. But the video also goes into the possibility of disease and invasive species playing a role.
Oh, yeah, that's a really interesting one. It's kind of chilling to think about. But the fossil record does offer some clues, like fossilized insects preserved in amber. They actually show signs of carrying diseases, and some of those diseases could have been devastating to dinosaurs.
Interesting.
So imagine a new pathogen. It's being carried by migrating animals across these newly formed land bridges, and it gets introduced into a population that has no immunity.
That's scary.
It is, yeah. And the video even talks about these giant stomach worms that they found fossilized alongside dinosaur remains.
Oh, yeah.
So parasites and pathogens, they can have a huge impact on ecosystems. And the video actually draws a parallel to the potato famine in Ireland, which was caused by a fungal blight that wiped out potato crops. And if a single disease can do that much damage to a human population, Imagine what a novel pathogen could do to dinosaurs that were already stressed out by all these environmental changes.
So we've got climate change, disease, and then, of course, there's the, what is it, the elephant in the room? Or should I say the volcano in the room?
The Deccan Traps, yeah. These were massive volcanic eruptions in what's now India. And they spewed out unimaginable amounts of lava and gases for hundreds of thousands of years, maybe even a million years, leading up to that Chicxulub impact.
Wow. The video compares the Deccan Traps to the Laki eruption in Iceland in 1783.
Right.
And even that relatively small eruption caused widespread crop failures,
Yeah.
livestock deaths,
Yeah.
even human fatalities.
Exactly. And the Deccan eruptions were just orders of magnitude larger than Lecky, so you can imagine the effect that they must have had on global climate and ecosystems. It's very likely that the Deccan eruptions were already pushing a lot of species towards a tipping point.
So maybe the question isn't really whether the Chicxulub impact caused the extinction, but more like how much of a role did it actually play in what was already a really dramatic ecological event that was unfolding.
Yeah, I think that's a really good point. And that's actually the debate that's happening in the scientific community right now. Like, what was the timing of the Deccan eruptions? How long did they last? What specific types of gases were released? All of those are crucial pieces of the puzzle.
And the video does mention some other theories as well, things like periodic comet storms or a nearby supernova bombarding the Earth with radiation.
Right. Those cosmic events are definitely intriguing. But the evidence for them being the primary driver of the extinction is pretty weak. We just don't see the kinds of geological or paleontological signatures that we would expect.
So it sounds like the dinosaur extinction wasn't just this simple open and shut case.
No, definitely not. It was a confluence of factors, all these different events, all coming together, and that complexity is what makes the story so fascinating.
And maybe even a little bit scary when you think about it. Like, it reminds us that ecosystems are incredibly intricate and interconnected.
They are, yeah. Yeah.
And that even the most dominant species on the planet can still be vulnerable to forces that are totally beyond their control.
That's true. And that brings up a really crucial question. What lessons can we as humans actually learn from the dinosaurs' fate? And that's something that we'll dive into a little bit later.
Yeah, definitely we should. But first, I think we need a moment to just kind of process all of this, because it's a lot to take in. You know, it's kind of eerie how some of what happened to the dinosaurs is like happening to us now.
It is kind of a parallel, isn't it? The video definitely makes that connection too.
Yeah, between like what happened to them and the threats that we face today, especially with climate change.
Most, yeah, for sure.
They experienced these massive changes in their environment, and obviously we're seeing similar things now.
Yeah, we are. But the rate of change is really the key difference, I think. Like, take the Deccan Traps, for example. Those eruptions released huge amounts of greenhouse gases. But they did it over hundreds of thousands of years. Humans are doing it in a matter of decades.
Yeah, it's like we've sped up the clock on the whole planet. And then there's that whole thing about disease, too. The way the video described how pathogens could spread across these new land bridges. I mean, it sounds a lot like how diseases spread around the world today.
Yeah, with global travel and trade. The interconnectedness of the modern world is great in a lot of ways. But it also makes us much more susceptible to these outbreaks.
Right, like we saw with COVID.
Exactly. That was a stark reminder of how quickly a new pathogen can just completely disrupt everything.
The video actually uses a really specific term for this kind of interconnectedness. Something about ecological cascades.
Oh, yeah, ecological cascades. That's a fascinating concept.
I don't really know what it means, though.
So basically, it means that a change in one part of an ecosystem can trigger this chain reaction, and that can lead to all sorts of unpredictable effects.
So like a domino effect.
Yeah, a domino effect's a good way to think about it. Like if you knock over one domino, it sets off this whole chain of events. And it's the same with ecosystems.
Okay, so give me an example.
Sure. So imagine you have a predator that keeps a certain herbivore population in check.
Okay.
Now, if that predator disappears for whatever reason, the herbivore population might explode, which could lead to overgrazing, and then the whole ecosystem could collapse.
Wow, so it's not just about losing one species. It's about the potential for this whole chain of consequences.
Exactly. That's the danger of ecological cascades. They can lead to a really rapid decline in biodiversity. And that makes ecosystems much more vulnerable.
The video also talked about biodiversity being like a safety net for the planet.
Oh yeah, biodiversity is absolutely crucial.
I mean, I know that it's important, but I don't really understand why.
Well, think of it like a diversified portfolio in the stock market.
Okay.
If you put all your eggs in one basket,
Yeah, you're going to be in trouble.
Right. You're much more vulnerable to risk. And it's the same with ecosystems.
All right.
If an ecosystem is dominated by just a few species,
The
and then one of those species gets hit by a disease or some kind of environmental change,
whole thing could go down.
right, the whole ecosystem is at risk.
So the more diversity, the better.
Exactly. Diversity equals resilience.
Yeah.
And the dinosaurs were so successful for so long, partly because of their incredible diversity. They occupied all these different ecological niches, and they were always adapting to changes in their environment.
But we're losing biodiversity now.
Yeah, that's the really worrying thing. We're seeing this decline in biodiversity all over the planet because of habitat loss, pollution, climate change. It's a major problem.
So what do we do with all this information? Like, what's the takeaway here?
Well, the video really emphasizes the importance of preparedness.
Okay.
We need to learn from the dinosaurs and take proactive steps to mitigate these risks.
What does that mean?
Well, it means investing in early warning systems for things like natural disasters,
Okay.
developing strategies to combat climate change,
Right.
and having plans in place to deal with pandemics and other global threats.
The video actually uses the Yellowstone supervolcano as an example,
Oh, yeah.
something we need to be prepared for.
That's a scary one. Yellowstone is a good example of how powerful nature can be.
For sure.
We can't prevent those kinds of events, but we can improve our monitoring capabilities
Yeah.
and develop evacuation plans to minimize the impact.
What about asteroid impacts? Can we do anything about those?
Well, the video talks about the importance of space exploration and asteroid detection programs.
Right.
We need to understand more about asteroids and their trajectories.
So we can, like, knock them off course or something.
Exactly. It sounds like science fiction,
It does, yeah.
but it could actually become a reality.
It's pretty amazing when you think about it.
It is, yeah.
It's a long way.
And that ingenuity, combined with a better understanding of how our planet works, gives me hope that we can handle whatever challenges come our way.
Yeah, I like that. A little bit of hope goes a long way.
It does, it does.
This whole deep dive has been pretty wild.
It has been, yeah.
We started with dinosaurs, and now we're talking about the fate of humanity.
It's all connected, though, right?
It is. It really is. I think the big takeaway for me is that we have a responsibility to learn from the past,
Absolutely.
like from both the successes and the failures, so we can make better choices in the future.
Well said. The dinosaurs are a cautionary tale, for sure, but they also show us the incredible resilience of life on Earth.
And the power of adaptation.
Exactly.
Well, I think that's a good place to wrap up this deep dive. But the conversation doesn't have to end here. Keep exploring, keep questioning, keep learning.
And who knows what other mysteries are out there waiting to be discovered.
Exactly.
Until next time.
Happy deep diving, everyone.